In today's video, we're going inside a giant rubber recycling plant, where old, worn-out rubber is collected, shredded, purified, and transformed into something completely new. Comfortable sleeping pads. From the garbage pile to your camping trip, this is one of the most incredible recycling transformations you'll ever see. So buckle up, and let's dive into the journey of how trash rubber is reborn into products that help us rest easy. Rubber is everywhere. Just take a look around you right now. Tires on your car, the soles of your shoes, the grips on your tools, even the floor mats in your office. It's tough, flexible, and built to last. And that's the problem. Unlike organic materials, rubber doesn't break down easily. A single tire can sit in a landfill for hundreds of years, slowly leaching chemicals into the soil and releasing toxic smoke if burned. Multiply that by the billions of tires and rubber scraps produced globally every year, and you've got an environmental nightmare. Instead of letting old rubber pollute our planet, they transform it into useful, everyday products, like athletic surfaces, playground mats, road materials, and yes, even sleeping pads. Sleeping pads made from recycled rubber are durable, comfortable, and sustainable. They take something that once clogged landfills and turn it into gear that supports hikers, campers, and disaster relief shelters. This is the story of how we solve one of the toughest waste problems on Earth, by turning old rubber into something that helps us sleep better. The journey begins at the collection stage. All across the country, used tires, rubber mats, factory scraps, and damaged industrial belts are gathered up. Some come from recycling centers, some straight from tire shops, and others from massive junkyards filled with mountains of rubber. Trucks deliver this material to the giant recycling plant. Imagine a warehouse the size of several football fields, stacked floor to ceiling with rubber waste. It looks overwhelming, but every single piece will soon be given new purpose. Once inside, the rubber waste goes through sorting. Workers and machines separate the usable material from contaminants like metal rims, plastic trims, and dirt. Powerful magnets pull out steel wires that were once embedded in tires for strength. Conveyor belts move tons of rubber to specialized stations where cameras and sensors check for impurities. By the end of this stage, we've got pure rubber waste, stripped of everything else. It's dirty, cracked, and worn out, but still packed with potential. The next step is breaking it down into smaller pieces, ready for transformation. Rubber in its original form is too tough to reuse. That's why the next step is all about shredding. The rubber is fed into massive industrial shredders, machines with spinning steel teeth that can chew through tires like they're paper. With a deep roar, the rubber is ripped apart into chunks about the size of your hand. These chunks are then ground even further into granules, some as fine as grains of rice. This granulated rubber is called crumb rubber, and it's the foundation for all recycled rubber products. Depending on the intended use, it can be coarse or ultra-fine. For sleeping pads, the texture needs to strike a balance, small enough for comfort, but still strong enough to maintain structure. As the shredding continues, the plant produces mountains of crumb rubber. Conveyors carry it upward into silos where it waits for the next phase, cleaning and purification. It's at this stage you can start to see the transformation. What once looked like trash, worn-out tires, grimy mats, is now becoming a raw material that can be molded into something useful. Even after shredding, recycled rubber is far from clean. Oils, dust, chemicals, and even tiny bits of metal still cling to the crumbs. To make a safe, high-quality product, the rubber must be purified. The crumbs are washed in powerful baths with heat and eco-friendly cleaning agents. Think of it like a giant industrial washing machine, scrubbing away years of dirt and grime. After rinsing, powerful dryers remove every drop of moisture. Then comes the refining process. High-tech filters separate any leftover impurities, while air classifiers sort the crumbs by size and density. The result? Clean, consistent crumb rubber that smells fresh and feels ready for the next stage. At this point, it's hard to believe this material once sat in a junkyard. It looks and feels almost brand new, but instead of going back to tires, it's about to start a whole new life. One that helps us rest after long days of adventure. Now comes the most fascinating stage, turning crumb rubber into sleeping pads. The purified crumbs are mixed with eco-friendly binding agents, special glues and resins that help them stick together. Imagine making Rice Krispie treats. The crumbs are like the cereal, and the binder is the melted marshmallow. Together, they form a solid but flexible sheet. The mixture is poured into giant molds shaped like sleeping pads. These molds are heated and pressed with tons of pressure. Slowly, the crumbs fuse together into dense, uniform slabs. When the molds open, out come thick, rubbery pads. At first, they're rough around the edges. Workers trim and cut them into perfect rectangles, smoothing the sides until they look polished. Some pads are designed for campers, lightweight, portable, and easy to roll up. Others are made for humanitarian aid, strong, durable, and able to withstand years of use in shelters. And because they're made from recycled rubber, they're far cheaper and more sustainable than foam or plastic alternatives. This is where the magic happens. Discarded tires, once considered worthless, have now become something that brings comfort and rest. Only the best pads move forward. Those that don't meet standards are recycled once again, ground back down to crumbs and re-entered into the system. Nothing goes to waste. Finally, the approved pads are packaged up, some headed for outdoor gear companies, others for relief organizations, and some straight to warehouses ready to ship across the world. Recycling rubber into sleeping pads is more than just an industrial process. It's a solution to a global problem. By giving old rubber new life, we save landfill space, cut pollution, and reduce the demand for new raw materials. For campers, these pads mean better nights under the stars. For disaster victims, they mean comfort in times of crisis. And for the planet, they mean less waste and more sustainable living. Every time we reuse something, we reduce the pressure on our environment. Rubber might be tough to break down, but with creativity and innovation, it can be transformed into something valuable again. If you enjoyed this video, don't forget to give it a thumbs up, subscribe to the channel, and hit the bell icon so you'll be the first to see more amazing transformations happening inside the world's biggest factories. Thanks for watching, and we'll see you in the next video. Water everywhere, but not a drop to drink. That's the paradox of our planet. Oceans cover over 70% of Earth's surface, but seawater is salty and unsafe for human consumption. So how do we turn this vast, undrinkable resource into clean, fresh water? Today, we're diving deep into one of the most incredible processes of modern engineering, desalination, the method that turns seawater into potable water. Let's follow the journey of a single drop of ocean water as it travels from the sea to your faucet. In many regions around the world, like the Middle East, parts of Africa, California, and Australia, freshwater supplies are dwindling. Population growth, climate change, industrial demand, all these factors put pressure on our natural freshwater sources. To fill the gap, countries are investing in desalination plants, massive facilities that convert salt water into safe, drinkable water for homes, farms, and industries. There are over 21,000 desalination plants operating worldwide, producing more than 100 million cubic meters of potable water every day. But how does it all work? The process begins right here, at the intake station. Massive pipes draw in seawater directly from the ocean. But this isn't just a straw in the sea. There's high-level engineering behind it. The intake is designed to minimize harm to marine life. Screens and filters block out fish, seaweed, and debris. Only water is allowed in, millions of gallons every day. From here, the water is pumped into the facility for the first phase of treatment. Before we can remove the salt, we need to remove the junk. That's where pre-treatment comes in. Seawater contains suspended solids like sand, silt, algae, and even tiny microorganisms. Through a combination of mechanical filters, chemical dosing, and microfiltration membranes, the water is cleaned of particles that could clog or damage the high-pressure systems used later. Pre-treatment is critical. If it fails, the whole system can shut down. Once the water is clean enough, it's ready for the most important step. Now we come to the heart of the process, reverse osmosis. This is where technology meets nature and flips it. Under normal osmosis, fresh water naturally moves through a membrane to dilute salt water. But in reverse osmosis, we do the opposite. Powerful pumps force seawater through special membranes that are so fine, only water molecules can pass through. Salt, minerals, bacteria, viruses, they all stay behind. It takes 600 to 1,000 psi of pressure to push the water through. What comes out on the other side? Pure, clean water. The salty waste called brine is separated and dealt with separately. For every gallon of fresh water produced, there's about half a gallon of brine. This super salty waste can't just be dumped back into the ocean recklessly. Brine is carefully diluted and discharged through special outfall systems that disperse it over large areas. Environmental agencies monitor the temperature, salinity, and ecological impact to ensure local marine life is protected. Newer technologies are also exploring how to reuse brine for salt recovery, industrial chemicals, or even as a source of valuable minerals like lithium. While reverse osmosis removes the salt, it also strips the water of essential minerals. So before the water can be sent to your tap, it must go through post-treatment. Engineers remineralize the water by adding calcium and magnesium, essential for taste, bone health, and pipe protection. Sometimes, a small amount of chlorine or UV treatment is added to ensure safety during transport and storage. Then the water undergoes rigorous quality testing to meet international and national drinking water standards. Only when it passes every test does it move on. Now the water is ready for delivery. Pumped through miles of underground pipes stored in water towers or injected into the existing municipal supply, this once salty seawater is now safe, clean drinking water. It fills bottles, feeds crops, quenches thirst, and in many coastal cities, it makes up a significant portion of the total water supply. Desalination is powerful, but it's not perfect. It's energy-intensive, expensive, and has environmental impacts. But innovation is rising to the challenge. Solar-powered desalination, nanotechnology membranes, and zero-liquid discharge systems are changing the game. New plants are more efficient, smaller, and more sustainable than ever before. In the future, we may see portable desalination units, disaster relief systems, and even desal plants aboard ships and space stations. As freshwater grows scarcer, desalination offers hope. It taps into a resource we have in abundance and makes it drinkable. But like all powerful tools, it must be used wisely, balancing innovation with conservation, sustainability with scale. In a world where water is life, desalination is not just a technology, it's a lifeline. This is just one of the many incredible processes we uncover. So if you're curious, inspired, or just love great storytelling, subscribe now and ring the bell so you never miss what's coming next. Beneath the Earth's crust, hidden in ancient volcanic formations, lie some of the most prized treasures known to mankind. Diamonds. For centuries, these shimmering stones have captivated royalty, industries, and investors alike. But their story begins long before they ever reach a jeweler's display. The history of diamond mining stretches back over 2,500 years to ancient India, the first known source of diamonds. These early gems were found in riverbeds and traded along the Silk Road, believed to bring strength, invincibility, and spiritual clarity. By the 18th century, Brazil had become the world's largest supplier, before the discovery of massive deposits in South Africa changed everything. In 1867, a young boy found a shiny stone along the Orange River, a 21-carat diamond that sparked a modern diamond rush. This led to the founding of some of the world's most famous mines, including Kimberley, home to the legendary Big Hole. Today, diamond mining is a high-tech global enterprise. The world's largest mines span across continents, from Jwaneng in Orapa in Botswana, to Mirny in Russia, Venetia in South Africa, and Diavik in Canada. Some operations reach depths of over 1,000 meters, and each year, more than 130 million carats of rough diamonds are produced globally. But how are these tiny crystals of carbon extracted from solid rock? And what does it take to bring them from the Earth's core to the world's most exclusive boutiques? Join us as we journey deep into the heart of modern diamond mining, a world of massive machines, precision science, and sparkling ambition. Geologists use satellite imaging, geophysical surveys, and soil sampling to identify promising sites. Once a potential kimberlite deposit is located, it's drilled and sampled to assess the concentration of diamonds. This process can take years and millions of dollars in investment before a mine is approved. Only a small percentage of kimberlite pipes actually contain diamonds in commercially viable quantities. If one does, the project moves into the development phase. In open-pit operations, huge amounts of overburden, layers of soil and rock, must be removed. The process begins with explosives, followed by massive hydraulic shovels and dump trucks that can carry up to 400 tons of rock at a time. This material is hauled to the primary crushing stations, where the hard kimberlite rock is broken down to manageable sizes for further processing. Once the ore is brought to the surface, it enters the primary crushing phase. Here, giant jaw crushers reduce large rocks into smaller pieces. The material is then passed through secondary and tertiary crushers to reduce it even further. By now, it resembles gravel-sized particles. The goal? To liberate the diamonds trapped within the rock matrix. From here, the crushed ore is sent into a washing and screening circuit to separate fine particles and slurries. These finer materials are essential because diamonds are often only a few millimeters in size.